What we're having a look at this video is how to factor a quadratic trinomial. You're also going to listen to my dog chew. We'll see how that goes. But it's a quadratic because we've got quadratic, 2 is the highest power, and it's a trinomial because it has 1, 2, 3 terms. 1, 2, 3 terms. Okay, so what we do is basically we're going to have to look for some factor pairs, and then things kind of work from there. Essentially, what we do is, I've never taught it this way, I've never explained it this way, but we're going to see how it all works out. We multiply the coefficient of our x squared by our constant term. So in this case, our coefficient of x squared is 1. So all we do is we do 1 times negative 14. Here, we're going to do 3 times 5. But like I said, 1 times negative 14 to give us negative 14. So what we're going to do is we're going to look for factor pairs of negative 14. So we can have 1 by negative 14. We could have negative 1 by 14. We can have negative 2 by 7. Or we can have 2 by negative 7. They're all factor pairs of negative 14. That. So what we want to do, we want to then add these factor pairs. And the idea is adding them to make this positive 5. We want to make the coefficient of x. So 1 plus negative 14 is negative 13. That's not going to work. Negative 1 plus 14 is 13. It's still not going to work. Negative 2 plus 7 is 5. That'll work. Let's just check this last one. 2 plus minus 7 gives us minus 5. That's not going to work. So it doesn't work. That is the thing that works. So then what we do is we say our factors are x minus 2 and x plus 7. Negative 2, positive 7, x minus 2, x plus 7. And that's what we do for that one. When we've got something like this though, it's a little bit more complicated. Firstly, what we're going to do, like I said, we're going to have to multiply these two things. But before we do that, we look and see if 3 is common. So whatever we've got here, is it common across these two? No. If it was, you would just take out that 3 as a common factor, and you would do the same thing as we did here. But because 3 is not a common factor, we've got to multiply 3 by 5. So 3 by 5, as we should know, makes 15. And what we're doing is we're looking for factor pairs of 15. So that we have 1 by 15, negative 1 by negative 15, 3 by 5, and negative 3 by negative 5. So now, just like over here, we look for factor pairs that added up to 5, positive 5. We're looking for factor pairs that add up to positive 16. Let's start from the bottom this time. Negative 3 plus negative 5 gives us negative 8. It's not that one. 3 plus 5 gives us positive 8. It's not that one. Negative 1 times plus negative 15, negative 16. It's not that. Must be this one. 1 plus 15 is 16. It is that one. So we say. So similar to what we did here, except we're going to break up this term into 1x plus 15x. So let's write that down. I'm going to use a different colour. So we're going to say we've got 3x squared plus 1x plus 15x plus 5. And then what we do is we split this up. We factor that thing and factor that thing. So what's common to both of these? And that is x. So we're going to take out x and we're left with 3x plus 1. Now we have a look at this. What's common to both of these here? 5. 5 is common to both, and it's a positive 5. So we'll say plus 5. And we're left with 3x plus 1. And now we have a look at this. I'm changing colours again. What is common to both of these terms here? 3x plus 1 is common. So we're going to take that at the front. 3x plus 1. And we're going to put the rest at the back. X plus 5, or the leftovers at the back. So that's where we factorise that thing. So to reiterate that, we multiply coefficient of x squared by our constant term. Coefficient of x squared by our constant term. In this case it's 1, so it's 14 or negative 14, and we look for our factors of this thing, our factor pairs of this thing. Whichever factor pair adds up to make this, we include in our sets of brackets. If we don't have 1 as our coefficient and we can't take this out as a common factor, we multiply this by this. In this case we have 15, and then we find factor pairs of 15 and we look for which factor pairs add up to this, and then we break that up. And that's all there is to it, really.